Okay, so today we're going to start Chapter 7. Chapter 7 is on ratio and proportions. So today we're going to talk about ratios. Now you've probably seen a ratio before. Keep in mind that there are 3 ways to write a ratio, and that's what's listed here in example 1. Remember, you can write it with the word TO. You can write it as a division problem. Actually, they're showing 4 ways. You can write it as a fraction, and then you can also write it with a colon. So these are the 4 ways that you can represent a ratio. Generally, it's going to be easier if you rewrite it as a fraction. And that's what you're probably going to be working with most of the time. So for each of these, they want you to simplify the ratios. So in example 2, I'm going to write them first as fractions, and then I'm going to simplify the fractions. So because a ratio is a fraction. So we can take the 32 and write it over 48, and then I can reduce this. I can divide them both by 16 to simplify, and this ratio would simplify to 2/3. Keep in mind that these are equivalent fractions. So the next one, again, I'm going to write 25x over 20x, and I'm going to simplify the ratio. The x's will cancel out, they'll become 1s, and then I can divide both of these by 5, or if you wanted to think of it as dividing by your GCF, which is 5x, and then my simplified ratio is going to be 5 over 4. And again, remember on all of these, we could also write them as 5 to 4. We could write them 5:4, or we could also write it as 5 divided by 4. These are going to be the 4 different ways that you're going to see a ratio expressed. Let's go ahead and take a look at the last one. We have 9x squared y divided by 6xy squared. Again, I could simplify my 9 over 6. I can divide them both by 3, and this would give me 3 over 2. And then for my variables, I could also simplify those. I could subtract these exponents, and then I would end up with, take away one of the x's here, and then take away this one, and take away this. So then I'm going to be left with an x in the top and a y in the bottom. And that would be your simplified ratio. Let's try another. So now here it says we can use ratios to compare 2 quantities. So here what we're going to do is convert. We need to know the conversions. So here we're going to convert and simplify those 3 hours to 15 minutes. So generally what you're going to do is convert the larger unit to the smaller unit. So for example, just make them the same unit. Sometimes you can make it into the larger unit, but in this case it's easier to make the larger unit into the smaller unit. So 3 hours. I need to know how many minutes are in 1 hour, and that's going to be 60 minutes. So I'm going to convert the 3 hours and make this, let me rewrite the problem. I'm going to convert my 3 hours into 3 times 60, and there are 180 minutes in 3 hours. And now that I've converted both the numerator and the denominator into the same unit, now I can simplify the ratio. And I can divide them both by 15, and this is going to give me 12:1. And again, you could write it with TO, with a colon, but you would leave that 1 there. So 12:1, 12:1, or 12 divided by 1. The next one, we need to know how many inches are in a foot, and there are 12 inches in 1 foot. And these are all prerequisite skills that you need to memorize. So you need to know the conversions. So for the inches to feet, I know that there are 12 inches in 1 foot. So again, I'm going to set up my ratio. 9 inches over 5 feet Again, I'm going to make the larger unit into the smaller. So to convert 5 feet into inches, I'm going to multiply that by 12. So whenever you're going to make a larger unit into a smaller unit, you always multiply by that conversion. So 5 times 12 is now, this becomes 60 inches over 9 inches. And now I can reduce my ratio, and it's going to catch up in a minute here. So I now have 9 over 60, and then I can divide them both by 3, and I'm ending up with 3 over 20, or 3 to 20. So you can't just take the numbers as they're given. You need to make the units the same before you simplify. Okay, the next one, it says the ratio of the length or the height of a tree that's 4 meters tall and the height of a sapling that's 50 centimeters tall in simplest form. So here we need to convert the meters into centimeters. I know that there are 100 centimeters in a meter. So I'm going to convert that. So I know that 4 meters is equal to 400 centimeters. So now I can put it into the ratio form. So now I have 400 centimeters over 50 centimeters. And then I can reduce. Now, I always like, whenever I see a ratio and I have a 0 on the top and the bottom, I always try to get rid of those zeros first. And now I have something a little bit easier to simplify. And I can divide them both by 5, and my ratio is 8 to 1. I have a little acronym that I use to convert within the metric system, and it's a rhyme. You probably should have already learned how to convert within the metric. My rhyme is King Hector drinks basically delicious chocolate milk. And each one of these letters represents a prefix in the metric system. So in my rhyme here, the K is the kilo, the H is the hectometer or hectogram, or it's just the prefix hecto. The D here, there's 2 D's here, but this one's deca. This B here represents my root word, and the B is going to represent the meter, the liter, and the gram. Then the 3 letters that are on either side will go in front of that root word. And then the next D is the deci, then the centi, and then the milli. So what you can do is you could take, for example, the C and put it with the M and make this cm, and that's centimeters. In between each one of these letters is 10. If you're going to go from a smaller unit to a larger unit, you would multiply by powers of 10. If you go from larger to smaller, you divide. So this is a little acronym to help you remember how many are in between each. So for example, from the centimeter to the meter, 2 jumps, so 10 times 10, 100. 100 centimeters in a meter. Little acronym to help you remember those conversions. The next thing we're going to do with these ratios are word problems. And in the homework this week, not only are you going to practice solving and simplifying these ratios, in each section you're also going to have some word problem homework. So you will get word problems on your test and quiz for this chapter. So let's go ahead and take a look at example 5. So notice here it says that Jenna plants alfalfa and wheat on 160 acres on her farm. If the ratio of acres of alfalfa to acres of wheat is 3 to 5, how many acres of each crop are planted? So whenever they give you a ratio in a word problem, what we can do is we can add a variable to each one of the numbers in the ratio. And then we would set up our equation. So again, they're telling us that wheat plus alfalfa, those acreages or acres are going to equal 160. So I'm going to take my ratio, the 3 to 5. I'm going to put an X with each of them. And because they want to know how many acres are on each, I know that the crop of the alfalfa plus the crop of the wheat equals 160 acres. So what I'm going to do now is add my like terms and solve by dividing. Now, what I find here is the value of X. To find out how many acres I have of alfalfa and how many I have of wheat, I take that X that I just solved for and plug it in to each. So here I would plug in 3 times, or 3x, so this would become 3 times 20. So 60 of the acres are going to be the alfalfa. And again, notice they're going to tell you which one is which. Notice in the description here it says alfalfa to wheat. So the 3 is the alfalfa and the 5 is the wheat. So 60 acres of alfalfa, and then you'll take the 5x, multiply the 5 times 20, and I get 100 acres of wheat. So again, one way you could check is when you add these, it needs to equal the total acreage that was on the farm, which was 160. So let's try another example. We're going to tie it into geometry. When you take geometry next year, they're going to tie all of your algebra skills into solving algebraic equations for finding missing angles and sides. So you're going to use all your algebra skills that you're learning this year in geometry next year. So let's go ahead and look at the tie here to the geometry. Here they're telling us the lengths of the side of a triangle are in a ratio of 3 to 4 to 5. It says the perimeter of the triangle is 24. Remember, perimeter means you add up all the sides. It wants us to find the lengths of each side. So again, I can add variables to my ratio. And again, remember, perimeter means add. So I'm going to do 3x plus 4x plus 5x. And I know that that total perimeter is 24. I'm now going to add all of those like terms on the left side. And when I add 3 plus 4 plus 5, I get 12. I now solve for x by dividing, and I get x equals 2. Now it didn't say to find x, it said to find the length of each side. So now I take each one of these, the 3x, the 4x, the 5x, and now I'm going to multiply all of them by 2, and that would give me the length of each individual side. So this would be 6, 8, and 10. And when I add those, just to double check, they do give me 24, which was the total perimeter. So again, in the homework tonight, notice you have 1 through 30 all. That's practicing simplifying and converting. And then you also have the word problems, the problem solving, and you're doing 2 through 14 even. So again, here are the written exercises. The first 8 you're simplifying, all on the written exercises, and then 2 through 14 even on the problem solving. Your homework is 7-1. Tomorrow we will cover 7-2, which would be solving proportions. And in 7-2, we're going to cross multiply and divide to solve these. And then 7-3, we'll get into the fractional coefficients. Any questions? Maybe I can introduce 7-2. Let's go ahead and go over that. 9 through 20, you're converting and simplifying. And then here we have word problems, but again, you're just putting them into a ratio. It's just phrases. And then, so you'll do up to number 30. And there is 1 through 30. The problem solving is over here and you're doing 2 through 14 even. So these ratios are going to be a good tool to help you probably when you take the PSAT and the SAT. Proportions are a good way to solve things. When you do this in geometry, there's a whole chapter on proportional sides in similar triangles. So this will come into your geometry lesson. So again,